Let's talk about applications of parabolas because they come up a lot in applications. So here's an example. Let's find the dimensions of the rectangular corral producing the greatest enclosed area split into 3 pens of the same size, giving 500 feet of fencing. So I drew myself a little picture. It's really hard to do these without drawing yourself a picture, if it's possible to draw a picture. So here's my pen. The outside is this blue, then the red, and the blue, and the red. So that's the total corral, and I'm going to try to figure out essentially the maximum area of that. So I'm going to give some things some names. So let's just say that the red sides, we're going to call those X because I don't know what length they are yet. And let's call all these blue sides Y. So this is also a Y, this is a Y, that's also Y, and then this top side is also an X. Okay? So my goal is to maximize the area. So I should probably come up for an equation of area. Area is equal to length times width for a rectangle. The length of this thing is X. The width of this thing is Y. So I have X times Y. Problem is I don't know how to graph something that has 2 variables in it. So my goal is to get rid of one of these variables. Well, the other thing that I know is that I have 500 feet of fencing. So I have 500 feet of fencing to essentially build the whole pen. So there's an X. There's an X. So in total, I have to build 2 of these X's. And you can see that I have to build 1, 2, 3, 4 of these Y's. So I need to build 2 X's and 4 Y's. And that is going to be equal to my 500 feet of fencing because that's the amount of fencing that I actually have. Well, you can choose which one of these you want to solve for. I'm going to solve for Y in this one. So 4Y is equal to negative 2X plus 500. Divide by 4, I'll get a negative 2/4 X plus 500 over 4, which means Y is equal to a negative 1/2 X plus 125. Okay, so what this means is my Y is equal to negative 1/2 X plus 125. I'm going to replace this Y with negative 1/2 X plus 125. I'm replacing what Y is in terms of X. So let me come over here so I got a little more space. 5x times y, well, that's going to be equal to x times my y, which was a negative 1/2 x plus 125. So now you can see that area is a function of x and only x. I don't have any other letter other than x in here. So I can think of area as a function of x. And if I send that other x through, this looks like a negative 1/2 x squared plus 125 times x. That's a parabola. I don't have a constant term, that's okay, but it does look like some ax squared plus bx plus c, just so happens c is 0 in this case. Well, I was trying to find the maximum area, and if you think about what this parabola looks like, the negative 1/2 up front is negative, so this parabola opens down. Since it opens down, I know it essentially has this type of shape, which means it has a maximum right here at the vertex. So if I can figure out where the vertex is, that's going to give me the x that'll make that happen. And overall, they want us to find the dimensions of the rectangular corral. So if I can find the x value of the vertex here, that's going to tell me what the x dimension is. So the vertex always happens at a negative b over 2a. They didn't specify how we had to find it, so I'm going to go with negative b over 2a. My b is 125, so I have a negative 125 over 2 times a, which is a negative 1/2. So I'm going to get a negative 125 over negative 1, which gives me a positive 125. So this is my x. Again, so my x should be built so that is 125 feet long. Okay. To figure out what the corresponding y value is, well, the cool thing is right here, I already have an equation that relates y with x. Y is equal to a negative 1/2 x plus 125. I now know x is 125. So if you plug that in, I have a negative 1/2 x plus 125. My x is 125. So I get a negative 125 over 2 plus a 250 over 2, which gives me a positive 125 over 2. So this is the y value. Okay, so if you think back to what my pen had looked like, it was something that looked a little like this. This side was x, drawn quickly, so forgive me. There's my y. We figured out the x and the y that'll make it happen. So the dimensions that produce the greatest enclosed area is my x is equal to 125 feet, and my y is equal to 125 over 2 feet.